more little question there, I think, from Dr. Grady. I know about the more recent launch delays, with the rocket checks and everything. But when was the original GLAST launch date? And what was the reason for waiting until this spring to?
I think we were, late 2007 or 2006 at one point. There were delays in getting the instrument completed, the large area telescope, in particular the tracker subsystem. There were delays in getting all of the towers delivered, and then more recently we had some challenges with the on the spacecraft side, completing the command and data handling electronics. Those were the two principal technical reasons.
Justin?
Justin Ray with spaceflightnow.com. A couple of spacecraft questions. When after separation from the launch vehicle do the solar arrays deploy, and how soon after the launch will you have initial state of health report on the spacecraft?
Well, we get data after the fairing is released, which I think is about 8 minutes or so. It's pretty quick. We'll get data from the spacecraft shortly after the fairing is released. So we'll be monitoring it all the way up to the point of separation. After the satellite releases from the second stage, the spacecraft will damp out any rates from the release event, and then within a couple of minutes the solar array will be released.
Okay, anything else, Justin? All right, come over here to Todd.
Todd Halverson of Florida Today with several, actually, if I could. First for Omar, you mentioned something about the locks on board and that constraining the launch window. Could you explain that issue and tell me how much of the launch window you actually have to work with?
Sure. Generally on a Delta II mission, what we do is we condition that RP1, the kerosene, to a certain temperature. We heat it. The concern is that the LOX on board, since the LOX flows through a duct right through the center of the RP1 tank, it would be cooling that RP1 to a point where performance would suffer. So we have about 60 minutes once the LOX is on board of usable window.
Okay, and at what point does LOX go on board? Is that at the beginning of the window? So do you really just have the first 60 minutes?
It's once we're complete with the full load, and we enter our window, we have 60 minutes of the usable time.
Okay, and could you discuss the most recent problem with your flight termination system batteries? And I believe that you have had a spate of problems with FTS batteries a year or so ago. I'm wondering if the recent problem is related, and if so, if that's an indication of a generic problem.
The FTS battery that was taken off the vehicle was exhibiting signs of a open circuit voltage of about 0.5 milliamps, which is well within the spec level. We don't start getting too worried about these until they reach the 1 millivolt open circuit voltage. And what you're concerned there with is isolation of the battery. The battery that we took off and dissected, by all means, would have worked just fine on this flight. It's a different type battery than what you've seen in the past. This is the second generation of it. We didn't expect to see an electrolyte leakage within the battery, but it did occur, and it is being monitored. The battery that we brought in was the OSTM battery from the West Coast. It's being monitored, and it's showing good signatures.
And for Dr. Steve, how do you explain to your next-door neighbor what the high-energy universe is, and what will GLAST potentially tell us about the birth and evolution of the universe?
First of all, my neighbor's a physicist, but my other neighbor, I explain that what we see when we look in other parts of the electromagnetic spectrum is very different from what we see with our natural eyesight, and that by building instruments to aid, or using our brains to build instruments to aid our natural senses, we're able to learn so much more about the universe. And I hope that you got a sense from what I discussed that, in a sense, what GLAST is doing is giving us a chance to peek behind the curtain or look under the hood for how things are working. And it's only by doing this sort of exploration that we're able to learn these things. And so it's, a form of scientific enlightenment, and that's what we're after, expanding our horizons for what it is that we think is possible. All signs had pointed down the road in this direction, and as John Morse had discussed a little while ago, the National Academy of Sciences felt that this was a very important high priority direction for NASA to proceed, and so that's why we're doing it. And I'm sorry, what was your second question? Did that answer your first question?
Yeah, I think you got both of them there. But just to follow, how prevalent are gamma rays in the universe that you and I know and see? And are they random? Are they uniform? Do they come from a certain part of the universe or all over the universe?
High-energy gamma rays are emitted really throughout the universe. And that's one of the reasons why they're such spectacularly interesting messengers. They're not very prevalent. They're quite rare. From the more diffuse and dimmer sources that we'll study with GLAST, for every gamma ray that goes through the LAT, there are about 100,000 charged particles, cosmic ray particles, that go through the LAT. And so we really have to find that needle in a haystack, and we do a lot of that with onboard processing and then through a very detailed set of ground-based analyses. So they're not very prevalent. About 2 times a second, a gamma ray from some direction will go through the Large Area Telescope and trigger it to read out. Gamma rays come from all directions. I think, as you saw, there are amazingly diverse features on the sky, as nearby as our own solar system and as far out as to the edge of the visible universe. And one of the challenges is to pick apart those different signals and listen carefully to the messages that the gamma rays are bringing us all this way.
Any further questions? All right. In that event, our launch coverage on NASA TV on Wednesday morning on the media channel will begin at 9:45 a.m. And for further information, you can go to the GLAST website, which is www.nasa.gov/GLAST. Thank you very much.